Hello, welcome. Welcome to this first video of mine. I wanted to share with you a recent project that I just completed on using machine learning with Python on children notebooks to essentially construct, you can construct any data set of pictures, of objects, of sign languages, of anything that you want. Essentially, and then being able to use TensorFlow and machine learning to train on this data set on the images that you capture. And with that, then be able to complete a model and then test the model to identify those objects real time. So let's get started. You'll find a copy of the notebook of this Jupyter notebook on the GitHub linked. You have obviously, if there's any questions or something doesn't look right, or you have any feedback, I do appreciate anything that you can comment or help constructively criticize, and we can always continue to make improvements. So let me get started. And I'll run through the code and run through what I've done, and as this progresses, and we will take it from there. So the first thing that we'll do is that once you download a copy of the notebook, just place it on any folder that you can create a folder on your desktop, anywhere that you want, and just drop that notebook into the folder. And then you would open up your Jupyter notebook. You would open that on a Jupyter notebook, and if you haven't done that or you're not familiar with that, this probably at this moment you'll need to step through, search other videos that are online that will show you how to get things installed, so that you have Jupyter notebook running on your browser, on your desktop. So let's run then through the first code. So what we're going to do first, or what this code will do first, is that on this first line, when you run this code, it imports the OS, the dependencies and packages that's needed. It'll create a label list, and from the label list, within that list of labels, then the first thing that it'll prompt you to how many number of objects you will be looking to train on. So, and then from that, once that is defined, so you enter an integer there, it'll then loop through that to those the number of objects, and it'll prompt you to enter for the name of the object. It's gonna enter that object name into the labels list, and it will in that folder that where you drop the Jupyter notebook, it is gonna create first of all a captures main folder, and within that folder, then it'll create both a train and a test folder with the label name, and then in the end it'll output that these are the objects on the next step, where we will be collecting all the pictures through your webcam video for training. So then we run this cell and show you what comes up. So enter the number of different objects to have this AI model that you will be building to train and recognize. So that means, let's say we'll do four for this exercise here. And then it is going to enter the name of the first object. So I got my four objects that I will be doing this today to show you. The first is going to be the ruler. Oh, let me take that right. Second object is going to be a scissor. The third object will be a pen, and then the final object that I'm going to have is a stapler. So once that's done, you will see that if you go back to the folder where you dropped the Jupyter notebook, you'll see that it will have created a main folder in there. And if you go through it, you'll see both the test and the train folder. And within the test and the train folder, you'll have those four different objects that you have defined, which right now will contain nothing. So if we go back to test. If you go to Tensorflow, same thing. So these are now folders created ready to start the image capture. All right, let's go back to the notebook. All right, so for this next step, we will make use of OpenCV to capture the images that we need to train and test the data set to capture the objects that we're looking for. So first of all, we import CV2. This here, where it says CV2 video capture, and there's one. So right now I have two cameras, two webcams that are attached to this laptop that I use. 0 would be the default, the one that usually is the built into the laptop. I do have a secondary one, and so that's why I'm using that one. It's a mobile phone, old mobile phone that I use, which has a much better camera than what is usually integrated on the laptop. So that is what I'm using. That's why there's a one again. So as defined here, you have more than one. You could use any number of cameras that you have connected to do the image capture. So we're going to iterate to the labels. So we have for this project we have 4 labels. So this iterate to it. It will the start. We define the start. So what this does is that it creates a CV2 frame with a capture rectangle. It'll show when we run the code, you'll see it. It'll be a rectangle where you would position the objects that you're looking to capture the images to train on. And so that is what this code below does. It defines the size of a rectangle. It then also we will only capture this in gray, or grayish, black and white. This can be adjusted for color, but due to what we're doing today, this is sufficiently enough. So then these if same in is that so that it doesn't start right away. It sort of pauses. So every time you hit enter to start the next, I guess the next step in this capturing. You'll see it when I start doing the capture on these 4 images. So it'll start capturing. Then it'll first capture into the train folder. And it'll record into it. It'll save the images in there, and then it starts with item 0 or item 1. The image count always gets reset to 0, and then 1 is added at the start. So it'll start with 1.jpg and all the way to the amount of images that you capture for that train set. And once that's done, you hit enter, and it'll start to collect a test set. Usually, right now, I guess this is just a recommendation. You can always do more, do less. So I'm going to do about 500 train images. I'm going to collect 500 train images and about 100 test images. So this gives about a 20% test image, and then a 100%, or well, if you say 500 is 100%, then 100 will be 20% of that split into train and test. And it stores it. It shows this IM show frame. The code has to be there for it to continue to display. This is just how CV2 works. And once so this key down here is that whenever you hit the enter key, then it'll go from start to train to test, and then every time then the image count gets reset to 0, so that it starts fresh. The counter starts fresh in renaming the labels. And then in the end, you'll see this cat release and the straight windows. This is when you're done, and it will release the resources associated with CV2 and getting this to work. So let me get this started, and you'll be able to see what we are doing. Let me start to run this code. Just give me a second here. So let's run this cell. once the cell runs, you'll see this frame pop up, and so this blue rectangle area is where you would where you're gonna it's a capture area. So that's where you're gonna be positioning objects to start capturing images of it. And as for this exercise, pen was on one of them. Once I hit enter, it'll start capturing. So let me get my pen ready. I'm gonna just position the pen within this area, capture area. What you want to do is you want to, once you start capturing, we'll go through it. So when I hit enter on my keyboard, you'll see that the counter starts. So it's capturing 100 images right now so far, and depending how you define how fast your computer is, it may be quicker or slower. And so I said we want to do for the train data set for each of the capture about 500. So right now it's 500. I'm going to hit enter, and it's going to start to collect the test data set. So these are right now being recorded, and I said 100, so I've gone 200. So let me stop that. So I hit enter again. So now it pauses. It pauses the capture. Next one is going to be the ruler. So let me pick up the ruler that I want to train on, and I'm going to position this again within the rectangle area. So this ruler is bigger than, but regardless, so just it'll be enough for a purpose. So I'm going to hit enter, and again the capture starts. I will move these. Try to move these a little bit. It helps with the training with the AI, with the machine learning, and be able to see different angles, different lightings, and different ways that. So now it's 500, and let me click enter. Now it's collecting the test data set. So once we hit 100, or I'm going to click enter now. So that's stopped on the scissors. So or on the ruler. Next one coming up is the scissor. We have the scissors that I want to train with. I'm going to just open the slidey. I'll close it. So then we hit enter. Starts the training data set. I'm going to turn it around so that you can get some good views. It's actually also training on my hand in this case, but again, depending on how you capture images, but if this is how I'm going to be showing it later on, then it works. So 500, let me hit enter. Now it's going to be collecting the test data set, and it's already 100, so enter. And then the last one I have for this core object is going to be my stapler. So I'm going to hit enter. Once I'm ready, it starts the capturing process, and I turn it around. Make sure I do a different angle. So there's an augmentation that will be doing that. Is doing some of this. So while you're capturing it, you'll see that this does it'll help. 500, 600. Press enter. Starts collecting the test data set. Turn it around. So 100. Press enter. So once that's done, you hit enter. When it hits the last, it'll release the capture, and then it'll destroy with this CV2 destroy it closes everything related to that CV2. So we are done with the capture of the train and test data sets. If you go back to the folder where you had your train data set, train test folders. If you click into this, let's say I go into train and I go into pen, I will see, for this, the capture 581 items. If I double click on one of them, it will see that it'll display, one of the photos, one of the capture images. So all of these now within here, if you go through the train, the ruler, the stapler, scissors, and then the test, this will have less amount. This is 171 items, so the amount of items that you captured during this last step that we run through. So now that that's done, move on to the next cell. This data augmentation is something within TensorFlow. It allows it allows manipulation of the data set of your images, such that it helps with the training. It helps with the machine learning. You'll see that right here. It does rotations. It rotates it slightly. It shifts it. It shifts it on the width, on the height. It can even flip it. So what this line of code does is that it enhances the data set using data augmentation. That's what it does. So first of all, this image row and column row, this is what we have, or what has been defined as the size of the images. I commented earlier that at speed. So because this is relatively small size when we're looking at the images for the laptop that I have, it can speed through it pretty quickly as far as capturing the images. I define a batch size here. This is a training batch size. You can adjust this again as needed. This is just it will also impact the training of the model when we train it, as far as how much of the data set it trains at a time. And it also has to do with sometimes if you have overfitting, underfitting, this is a number you play around. So if you're not familiar with TensorFlow and retraining, then I suggest that you need to. There's ample videos on YouTube that helps define these, as well as courses. I love both free and paid courses online that goes into machine learning and TensorFlow and training and what needs to be done as far as to getting your data set ready and preparing that for training. So the train dir here this is where we have captured our training data sets, and the validation dir is where we have captured our captured images. This train data generator or image data generator, it is a function within TensorFlow and Keras that allows us to be all assembled into a data gen, what usually it's termed, but you don't have to term it that way. But using this data generator, then you create a train generator, and then this is what we can feed into the TensorFlow model for quicker training to speed up the training, just a function of it. So now let me step through this cell. And we're down to training the model. This model here that's defined is a TensorFlow training model. The model in and of itself it's a sequential model. There's different ways of defining this. So you can do a function. You can do a pipeline. But this right now is just one of the methods that can be achieved. Within the schedule, we are doing a CNN or a convolutional approach in training this model. So we go through, we do a convolution of 128, and then the filter of 3. We do a ReLU, a rectified linear unit activation. And then we define the input shape, which is what the size of the image is of 128, 128. And this one defines the color. Since we are using just black and white or grayscale, then it's just a 1. RGB would be a 3, but for this purpose, then it does a max pooling. We then continue with another convolutional step in it, where then we're doing the 96 with the 3 on the filter and an additional rectified linear unit activation. And following that, we do a 64. We flatten then our output from that, but then we pass it to the dense layer. We add a dropout to again improve our data set and the augmentation. Then we pass it back into a dense. So this last dense here was this train generator number of classes. This actually pulls the number of classes from the generator. If you see this code here, where it found these 2,374 images belonging to 4 classes, it's going to get that .4. So for yours, if yours 10 or if you're doing 5, it'll get that. It'll tell or the model that with the softmask activation that in the end it'll separate into the number of classes that the model trained on to be able to then be able to predict on. Let me run this cell, and you will see since I have a model.summary, you'll see that with this model, this sequential model that I have defined with the number of layers and the steps within it, that is the total trainable parameters for this model. It's going to be 1,700,073 parameters to train on. So next, we're going to compile the model. We are going to this is standard model, standard compilation, I guess definitions for a model such as this. It's a sparse categorical cross entropy that's defined for the loss because this is going to be a multi-class output. We have a accuracy for metrics, and then the optimizer where I have defined a learning rate of 0.0003. So this is lower than the standard learning or default learning of 0.0001, or actually 0.001. And this is done to when I was developing this project, I went to a different analysis where I was calculating the learning rate, decay on the learning rate, and in that testing model run, where it steps through different numbers of learning rates. This 0.003 was defined to be about the optimum range for this model. The way it's constructed, the way the images are, the size of the images, the approach that this is done. So again, this will change, and this is a rate you can play with if your model is not not training, not getting the right, it's either underfitting, overfitting, or not getting the accuracy that you are wanting to reach for your model. So then we fit the model, and then we can start training on it. So then we get this started, and I'll at least show you the first step before I pause this video, and then come back to you when this is done training. So the model has completed training on my end. If I look at the results, so it started with a validation accuracy of 0.76, and as it continues to train, you'll see that probably didn't need to change for so long, but so at epoch number 9, validation reached 1, and then so it starts to then just overfit maybe slightly. But in the end, so we achieve accuracy on the training data set of 0.993, and then the validation actually of 0.918. So that is done with the training for this model. This next code here is going to save your model in H5, and I need to do that. I'll show you why I need to do that. So, and that's done. And then so it saves a. If I go back to the folders, if you go back to your base folder, you should see your captures folder, obviously, and then you should have a model that was saved with the last cell, the step that was just done. So, and I need to do this. So perhaps you don't need to do this, but this will save now your model, and then you don't need to go through the above steps anymore. Next time you can just do the model for this next step. And let me show. So the reason why I need to do that is that because I have a, let me show you, I have a GTX 965M video card on mine, and whenever I run models or it's going to use up all the memory. So right now you'll see this dedicated GPU memory is close to 2 gigs. So use it all. If I now try to run the object detection, it'll crash crash out my computer. So what I need to do right now is, if I go back to my Jupyter notebook, I have to restart this kernel. So when I restart, then everything gets lost. So that's why I can load the model back on and redo this. So when I restart, so once this restarts, if I show you now you'll see that my dedicated memory usage has now gone back down to an acceptable, operating level. So anyways, let me go back here. So we're now going to load the model. So let's wait for that to be done. So that's loaded the model. And then we need to, for this next step to work as well, I need to recreate the labels list. So this labels list is going to go through your folders, and then it's going to just add for the label that are in this capture change folder. It'll create a labels list. So I created pen, ruler, scissor, and stapler, which are the labels that we or that I train on. The 4 things that I defined for this exercise. All right. So this next code is this is the object detection portion then of the notebook, and this is the final section. So it again uses CV2, and then it'll recreate the frame again, and within that frame is gonna be detection box. So this detection box is gonna take it. It's gonna watch what's in that frame. It'll detect it. It'll reshape it to this. This is what needs to be done because this is how what I trained the model on, or define the model on, which is this size, this 128, 128. And this the detector then gets divided by 255, which is also what was defined earlier. This 255 is so the colors are usually in this 250 has to do more of the color, the grayscale. Well, it comes from usually defined from 0 to 255, and what machine learning does, or right now I guess in the way it is defined today, is that if it can be within a range of 0 and 1, and so if anything between 0 and 255 divided by 255, then you get the equal aspects of aspect within the 0 to 1 range definition. And so this matches also what was done earlier on the model. If you go back to the code, before the images were trained on or tested on, it gets divided by 255. So then the model is able to do a prediction on that value, and then this confidence. Then so this is going to give me 2 things: the prediction as well as there's also a confidence level that it will give, and then those 2 are then fed into this confidence, into this prediction. Then it'll display the label using this labels list. This MP argmax will pick between 0, 1, 2, 3, which are the labels, and then it'll define that, or it'll output that. And then here, the next area here is the confidence level. So if the confidence is going to be less than greater than 50%, it'll be you'll see green prediction confidence outputted, and otherwise it'll be red. So let's run this code, and I will show you. So see if that's going to work. I don't crash out of this. And sorry. Okay. So right here. So you'll see that it is running now. So there's a default prediction always. So you'll see that if in ruler, is our default protection. Because how do I explain this? So the ruler is 0. So 0 is basically the default protection. So we go back to captures and train. Your pen ruler, and so ruler in this mode is what's being defaulted. Let me now. So if I use my scissors, you'll see that, and then it'll tell you with what confidence it can predict that this is a scissor. So if its prediction is less than 100% or less than it tells you, all right, I'm predicting that this is a scissor, and this is what you see. All right, scissor, got a stapler, real-time object prediction with a stapler, and you'll see that it was flashing red a while ago because it wasn't too sure that this is a scissor or stapler. It wasn't too sure it's predicting. Yeah, let me see. Yep. So yeah, it's predicting something different now, and it's not sure what it is. So you see the ruler? Well, yeah, it's defaults to ruler, so that's what it is. And then got a pen. All right, so if I pick something else, another pen, it's a red pen, but because it's very similar, this is what it tells you what it is. All right, so there's something that's such as this scissor. Let me see if I do a toothbrush. All right, so this it seems like a scissor or a pen. So it has four different labels that it can predict on, and so it's going to display one of those four labels. So if you train on more labels, there will be more labels, but it always is going to set up to define to say one of them. So, but again, so that is it, and this is the project I've been working on. I just wanted to share this with you. It'll be in GitHub. Please comment. Look forward to doing more videos as things that I continue to research and work on, and we'll be able to share this with you. And well, thank you all. Let me try to close out of this. So actually, if you click enter on this frame, it should exit. All right. Okay. So it's exited. It's done. I just have this last here. Just something like I said, I was getting some or the system hang, and I have to just reset it. So thank you all. All the best. See you next time. Bye.